Yes, Sat Shri Akal students. Today we are going to discuss arithmetic operations with significant figures. Students, you see, we are doing multiplication, division, addition, and subtraction with so many variables. Now, all the variables are measured with certain degree of accuracy, means they have some significant figures. Now, when our arithmetic operations are completed, so we get a compounding result. The question is, how many significant figures must be there in the compounding result? For example, let's say mass is 4.237 gram. Now we know it has four significant figures, and volume is measured as 2.51 centimeter cube. Now we know it has three significant figures. When we calculate density, that is rho is equal to mass by volume. So we will get the answer as 1.6880478087 gram per centimeter cube. Now it is absurd to report the value of density in so many digits. In fact, it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 significant figures. Not useful. Now we have to define some rule. How many significant figures or how many decimal places must be there in the compounding result? So that is our aim for today's lecture. That's what we want to understand. Once you see the complete video, students, we will explain the compounding results in multiplication, division, addition and subtraction with few examples, followed by permissible error in the result. So students, we leave it here and we discuss the addition and subtraction first. Addition and subtraction. Now, let's see the rule. In both additions and subtractions, the final result should retain as many decimal places as are there in the number with the smallest number of decimal places. With smallest number of decimal places. Now what is this number? So these are the values of the variables we talked about. Now let's say we have x is equal to 3.8, some variable, and y is equal to 0.125. Now students, when we add both of them, that means we do x plus y, it should be 3.925, but the rule says the final result should retain as many decimal places as are there in the number with smallest number of decimal places. Now x is the number we are talking about, this has smallest number of decimal places. It has only one decimal place, one decimal digit after the decimal. So now our final result, that is x plus y or x minus y, should also retain same number of decimal places. That means after the point there should be only one decimal place. Now what we do, we want to convert this, or we want to round this off to one decimal place. Now we will apply the five formulas, five rules we have discussed last time to round off the decimal places. Now here we want to convert this into one decimal place. This 2 is less than 5, right? We want to drop 2, right? So we want to drop 2. Yes, so students, 3.925 will be round off to 3.9 only. So x plus 5 will be 3.9. Now we can take another example. Let's say x is equal to 12.587 and y is equal to 12.5. Now let us see what will be x minus y. Now x minus y, when we subtract 12.5 from this, we will get 0.087. Right? Now the rule is, we this compounding result, the final result should have only one decimal place after the point. Now only one digit should be there, like in this. So we will round it off to one decimal place. So here it is more than 5, so preceding digit will be raised, so this will be equal to 0.1. This will be the answer. This is how, students, we do addition and subtraction. It is very important for you to note down this observation, students, that in arithmetic operations with significant digits, the final result of compounding any number, I repeat, the final result of compounding any number of variables should not have more significant figures than the original data from which it is obtained. So, means, as in this case, you see, this has 4 significant digits and this has 3 significant digits. The final result cannot have more than 4 significant digits, but it's there. So this is wrong. So we will learn how to correct it, right? When we do multiplication and division. Just wait. Yes, students, now we will discuss multiplication and division. See, the difference between the rule in addition and subtraction and multiplication and division is, students, very simple. Here we are concentrating on the decimal places. Means the final result should retain, as many decimal places as there as are there in the number with smallest number of decimal places. Just replace decimal places with significant digits. You will get the rule for addition and multiplication and division. So what is the rule in multiplication and division? The final result, the final result, students, will contain as many significant figures as are there in the original number with smallest number of significant figures. I repeat, the rule for multiplication and division: whenever you are multiplying and dividing some variables, so final result will contain as many significant figures as are there in the original number with smallest number of significant figures. That means, let's say 1, 2, 3. Three numbers are there. In this number, significant figures are 4, in this are 3, in this are 2. So result will contain only two number of significant figures or significant digits. Let us take a example. So students, the example is, we can take x is equal to again 3.8, and students, we can take y is equal to 0.125. So what will be x into y? So x into y will be 3.8 into 0.125. Well, actually that is equal to 0.475. Now, here how many significant digits? 2, and here significant digits are 3. And here also significant digits are 3, right? So this is okay. You know, uh, no, I'm sorry, this is not okay. Here significant digits are 3 and here significant digits are 2. So it should be equal to 2. That means we have to round off this to two significant figures. That means we have to round off this decimal to, two digits after decimal. So what will be the case, students? It will become 0.4 8, right? This is the answer. Now students, we will, because we know the rule for multiplication and division, so we can do the sum with which we started this lecture. Now, can anyone tell how many significant figures should be there in the density? Yes students, how many significant figures are there in this 4, and here there are 3. So which number has
Two,
number of significant figures? Volume,
2.5.
right? So this density should have only 3 significant figures. So this will be equal to 1.6. Instead of 8, we will write 9. Very right. We will drop this 8. When we drop this 8, the preceding digit, because it is more than 5, will be raised by 1. 1.69. Students, I would wish that you please see the previous video. The link is given, to understand how to round off the digits. Okay. So let's go further. We have done this also. Now we can do a simple sum. Let's say we have 876. It has no decimal, plus 0.4382. So once we add them, students, we will get 876.4382. But our rule says, so you remember, in case of plus and minus, we concentrate on decimal points, right? So the compound rings result will have as many decimal places as are there in the number with least number of decimal places. In case of multiplication and division, we will concentrate not on decimal points but on significant figures. So जो फाइनल रिजल्ट है उसमें 2 या 3 या 4 जो इनपुट वेरिएबल्स हैं उनमें से सबसे कम जिसमें सिग्निफिकेंट फिगर्स है फाइनल रिजल्ट में उसके बराबर सिग्निफिकेंट फिगर्स होंगे, right? So here, because it is addition and subtraction, so this has no decimal places, am I right? So final result should also have no decimal place. This should be equal to 876. Let's take another example, students. Let's say we have 8.0 minus 0.42. So this is equal to, students, 7.8.0 minus 0.42 is equal to 7.58. So what is the rule? Can anyone tell me the answer? Yes, Amitoj Singh, can you tell the answer?
Five. No.
So, you see, now we will concentrate on 8.0. This has one decimal place, right? One digit after the decimal. So here also we should have one digit. It will be rounded off to 7.6. Decimal digits after the decimal is 1, and in here also it's 1. Very right. We have done this. We can do some more sums also, students. Like you see 0.995 9995, let's say 3 times 9 into 1.53 divided by 1.592. So first of all, what you do, students, simply divide divide them and multiply them like we have to do normally. Okay? Then the answer you are getting is 0.96057. Right. But in multiplication and division, we concentrate on significant figures in the number having least number of significant figures. So here significant figures are how much? 4. Here they
Four.
again 4. Here they are 3. So our concentration will be here. So final result should have 3 significant figures. So now this will be rounded off to what? 0. Yes, students, anyone can say 0.965.
961.
So it will be 961 will be the answer. Very right. You can still do some more sums, students. Give me some, uh, give me 1 second. Let me take some more sums from the book. Mm, just give me 1 second. Yeah. So he says find the density. Density is equal to mass by volume. Mass is 5.74 gram. And the volume is 1.2. Then this will be equal to 4.783 grams per centimeter cube. Am I right? So what will be the answer, students? In division and multiplication, this has two significant figures. This should also have two. So it will be 4.8 grams per centimeter cube. Students, yeah, let's do one more tricky sum. You see, we have to add 6.75 into 10 raised to power 3 centimeter plus 4.52 into 10 raised to power 2 centimeter. Okay, students. So now these are not like terms. They cannot be added. To make them like terms, students, we have to see that uh, the power of 10 should be same. Then only they can be added. Now the question is whether it should be 10 raised to power 3. We should go by this, or we should go by this, that is 10 raised to power 2. So students, uh, see, if we go, we will do both. If we go with 10 raised to power 2, see what's happening. Let's say we convert this also to 10 raised to power 2. So this will become what? 0.675 into 10 raised to power 2 plus 4.52 into 10 raised to power 2. Now the problem is, students, the number of digits are increasing here. Am I right here? Number of digits after the decimal are increasing. Am I right? So better we go for 10 raised to power 3 only. So this is like 6.75 into 10 raised to power 3 plus how to convert this into 10 raised to power 3, students? So it will be, tell me, point 452 into 10 raised to power 3. Very right. So this will be 7.202 into 10 raised to power 3 centimeter. Right? Now, you see how many significant, how many decimal places are there in this? 2. Here also 2. So here also there should be 2. So it will be 7.20 into 10 raised to power 3 centimeter. Okay, if we do like this, then let's see what happens. If I do this into 10 raised to power 10 raised to power, okay, so fine, so we'll do like this. Okay,
Excuse me, sir.
yeah, tell me.
Sir, in that second case, 0.675 into 10 raised to power 2. But when we convert 6.75 to 10 raised to power 3 to 10 raised to power 2, then 67.5 will not be there.
This is wrong, you're right. It will be what it will be, actually this is
67.
750, right? So if I say into 10 raised to power 2, it must be 67.5. बिल्कुल ठीक है. So the thing is, that is the reason 2 नहीं किया, because if you do 2, the decimal place is decreasing. Am I right? Decimal place is decreasing, then result will also have one decimal place. That's why we are going for 3 only. Okay? I wish you all the best. Have a nice time. Students, Monday is your test for this entire chapter. Okay? At 11 o'clock, your test will start. Please, on Sunday, revise everything. Please see all the videos. This is the best way for the revision. You need not to.
7.5 into 10.
What?
सर काला
हेलो बोलो जी जैस्मिन
सर कादा टेस्ट आ
हाँ ये जड़ा टेस्ट है ना फिजिकल वर्ल्ड एंड मेजरमेंट फिजिक्स दा
ओके सर
फिजिकल वर्ल्ड एंड मेजरमेंट ठीक है ਇਹਦਾ ਟੈਸਟ ਆ ਸੋ